Good morning. Good morning, and thank you for being here. This is a talk essentially devised to compare and contrast from mostly a web perspective, responsive web design, and device detection. So the essence of the presentation is which options we have to make our web pages, web front ends, web views, HTML content, whatever, from purely a browser perspective, but also for web views we may have embedded in a mobile native application, what we can do actually to detect the real capabilities of the device. And the interesting thing is that this talk comes again to compare and to contrast the other approach, the other camp, the other vision that has been predominant for quite a while in the industry that says we don't need to detect devices, we don't care about devices, we don't want to waste time and effort, energy, brains in trying to figure out the most effective way to effectively analyze devices. We just try to do, when possible, feature detection. So via the DOM, via the document object model, we try to check whether certain features are available, and through check against nullness of objects, we understand whether certain things can be done or not, and we code appropriately. The other philosophy says, okay, sometimes this is not, sometimes, I would say almost always, except very basic situations, which are anyway common, this is not enough. But when we try to take a different approach, we go against the wall represented by the technical difficulties of understanding the mechanics of devices. And the central point of the thing that makes really hard to understand the underlying devices being used to visit our web pages is the user agent string, which is something, it's a long string, well, not really immensely, massively long, but it's a few, could be 100 to 200 characters typically, but not really intelligible for most humans. Something like Mozilla, and by the way, Mozilla is there, but it's totally ignored. It's there for some sort of backward compatibility. Then we find that typically in a string made of column-separated chunks, something like in this particular example, MSIE 10.6, which identifies in particular Internet Explorer 11, then we have something that typically identifies the operating system, and then some weird strings, SLCC1, no idea what it means, InfoPath 2 point, no idea what it means. Trident has, in this particular case, to do with the rendering engine used by the browser, which means that it could be a different string, but not necessarily in the same position within the overall buffer to identify the rendering engine of other browsers. In this case, again, is Internet Explorer. Then something else that, in this particular case, identifies the operating system, or specifically the CLR, the virtual machine, being used. A browser user agent string, to cut a long story short, is the signature, the only piece of unique information we can rely on when we try to identify from the browser, from the code we host in the browser, the nature of the browser itself. And the interesting thing is that essentially we rely on the information that the browser makes public to try to figure out what kind of browser we are in. That's interesting because I'm not sure if it ever happened to you, but I can bring my very particular experience. I bought, for testing purposes, an Android device from an unknown company, Media something. So just the cheap Android tablet device. Okay, we run on this device, we pointed just the browser to a particular website which was doing some sort of X-ray analysis just for testing the API that I will be presenting later on for device detection. And to my greatest surprise, the response was, welcome to your iPad. Come on. Look, this is an Android device running Android 4.0. But the analysis tool was saying, welcome to your iOS iPad. This is iOS, whatever, well, version 6 point something. Okay, after a further analysis, it looked like the browser mounted natively on that Android device was using exactly the same user agent string of one of the earlier versions of an iPad. So, and there's nothing at that point you can do to try to fix things. No way, because the user agent is the only piece of information you can rely on to understand. And the alternative is feature detection. So use the DOM and try to see if certain features are implemented. But the interesting thing is that in both cases, you are limited to what information brought the specific browser and the vendor, and sometimes, especially on mobile devices, it's not the browser, so the Google that prepares Chrome or Apple that prepares Safari, but it's just the vendor that gives you the hardware, that packages software on the hardware, that decides, the OEM decides what kind of string they have to put there. And they tend to hide some information. They tend to, or in some cases, to disguise. That was a ridiculous mistake, probably. But in that particular case, an Android was presenting itself as it was an iOS device. Feature detection has been pretty popular. It also looked a smart kind of thing, but not all features. Not all pieces of information you might want to be aware of to organize your code can be detected as features. Want an example? The operating system. There's no way, no reliable way. Yes, if you Google for, if you check the navigator, the window object of most DOMs, yes, you find something that points to the operating system, but it's very, very generic type of information. For example, there is no way to detect reliably a Windows Phone device because all you get is Win32, which is pretty generic as a piece of information. Or you get something like Android. Android what? But even if you have the number, the version number of the operating system, it doesn't tell you anything about whether it's a smartphone running that version of Android or a tablet or whatever else. So feature detection is sometimes possible and effective to use. In many other cases, it is not. And it's not a matter of religion here. It's just to see which options you have and decide in the context of the specific application you are writing what is best for you. Because not all applications need to do in-depth device detection. In many cases, responsive web design which just ignores the capabilities of the device is enough, but it's not something that may work for everybody. And the world is full of use cases of companies, even large companies, mostly social networks, that took different positions over time versus responsive web design and serving different markup based on the capabilities of the device. So to cut a long story short again, if checking the user agent string was an easy task, we had no problems. Everybody would be checking the user agent, and then we probably would have had available frameworks to simplify to the greatest amount the task of switching behavior between cases. And checking user agent is problematic because of the total unpredictable nature of those strings. There are way too many cases. I would say in the order today of the 30K, maybe more. Last time I checked, a couple of years ago, it was one of the most popular frameworks that provide client and server side device analysis a couple of years ago was around the 25K or 25,000 different user agent strings checked in their database, and that was 2 years ago. So the number is, I said the 30K, but it could be even more. But that's a few tens of thousands. That's the order of magnitude for the different use cases. So we are not talking about setting up a huge switch statement which, where each entry represents a possible behavior. So we are not talking about that. When we say checking the user agent to extract information, we are talking about categorizing in a smart way, algorithmically, all this 30K or whatever, 50K or etc., different user agents to categories, and then extracting mechanically but also via human knowledge capabilities. Just to give you an idea, a smart tool that does analysis on the user agent is capable of telling you whether a particular device is able or not to play videos. But in this case, in the true-false value you get for a particular capability, can play video of a certain type, MP4, whatever, the yes-no is determined not strictly by the technical capability of the GPU mounted on the device, because there is a GPU, so technically it is able to play a video. But human experience, so, and that is the cost of maintaining such a framework, is the human experience that says, well, it can do that, but you better not do it. You better avoid, you better not play videos on this particular type of device. So now, not every application, not every web page, not every website needs this level of detail when it comes to features like playing a video. In most cases, even if you host videos in some of your pages, okay, poor the user who happens to visit your site with that device. But if it's critical, and that depends on the business you run, you cannot simply rely on responsive web design to make this kind of detection, and not even you can do that with feature detection, because feature detection will simply tell you whether or not videos, there is an API available to play videos, but not the human extra service of telling you, yes, but don't count on that. It's not reliable. Complex analysis, sophisticated analysis takes a lot too. A lot means you need an infrastructure in terms of code, in terms of people, in terms of weekly or daily effort to keep the database up to date. This is a fact. But effort depends on the expected results. So if you simply need to determine whether you are running on an iOS or an Android operating system because you just want to change the CSS, regardless of it's a tablet or not, that's easy. You don't need any framework. You can just grab a bunch of scripts from Stack Overflow or other forums and go. There's no big deal. It works. It depends on the target you have, on the expectations you have. So the highest are your expectations in terms of results and details, the more you must be ready to invest, mostly in terms of understanding and knowledge of frameworks. So what do you expect? Scenarios very simple to handle are, you just want to know if the device is a desktop or not, or whatever else. That's easy. You can simply check the user agent, and you can do that easily from JavaScript, just for a few 10, 20 keywords. If there's Android, if there is iOS, if there is a Windows Phone or mobile, or we can run, or some other names, mostly from telecom companies, probably 20 different strings to check for. Just literally via regular expression is enough. And there are plenty of scripts you can find and download and integrate in your code. So that's pretty easy to do, and there is no need to do anything particular or checking very special frameworks. Yes, also if you just need a rough checking of Android versus iOS, just to change the CSS, it's easy to do. But determining whether it's a tablet or a smartphone, that starts getting problematic. And the tricky thing is that as far as the operating system is concerned, the easy answer is just check for any of those iOS or Android. And 90% of the time you get it right. Probably even more than 90% of the time you get it right. What about determining if the form factor, tablet, smartphone, or whatever else? In that case, you can mix up this behavior with advanced capabilities of responsive web design. Not much the current version of responsive web design, which is based on CSS media queries version 3, but the upcoming version 4 of CSS media queries provides a bunch of more capabilities specifically designed to simplify the task, so the queries that identify tablets. So there are in the upcoming CSS media queries standard properties that reason about the size of the pointer. So you can determine if it's essentially it's the finger or if it's the mouse. If the browser tells you correctly, because you still rely on the browser implementation, but if the browser doesn't lie about the supported version, the supported size of the pointer, the media queries offers a word to put in your queries so that you can change a CSS if the finger is the typical pointing device for that particular browser. So most of the time that could be a tablet, but it could also be a smartphone. Yes, but combining width and size of the finger, you can easily distinguish between smartphone and tablet. But yes, it's still something that relies on the results from the logic you implement using low-level tools and still relying on what browsers, if browsers implement the CSS upcoming, not here yet, CSS 4. Because as far as I know, some latest versions of Chrome offer support for, early support for CSS media queries 4, but it cannot be called out to be widely supported as it is the previous versions 3. And versions 3 is only limited concretely to let you check the size, the width of the screen. That's it. And the width of the screen is not entirely reliable, as we'll see in a moment. So if you are checking for specific capabilities, like can it play reliably a video, or if you're checking for an exact analysis of the browser name or the operating system name, this is not something you can do with JavaScript without a deep analysis, algorithmic analysis of the user agent string. But because checking user agents has always been a tough problem that many people recalls from the early days of web development, when every web page had, if it's something, checking for MSIE, that's Internet Explorer. It's Netscape, if contains Navigator, it's Netscape, else it's Safari. So in the beginning of web development, we had, in most pages, 5 or 6 branch switch statement checking for different top-level desktop browsers. If we keep into account the huge number of mobile devices beyond the computers, you see you've got from 5 to 6, you can easily go to thousands of cases, and that is absolutely crazy. So we said a few years ago, as developers, because as developers we like when we can prove ourselves to be smart, let's get smart. So if detecting devices is hard, just ignore devices. We are so smart to rely on CSS media queries. Let's use media queries. Focus on facts because we want to be smart. And we made that. We turned a great idea. So because responsive web design is still great at letting you implement a per device changing UI quickly, easily, not always effectively, but still easy to do and working in quite a good number of situations. Responsive web design, you know the picture, whatever is the content, it displays according to the real size of the device, whether it's a desktop, whether it's a notebook, a netbook, a tablet, mobile phone, whatever. And it relies on CSS media queries as the inspiring technology, which essentially is a string you assign to the media attribute otherwise unused. Because the media attribute in the link HTML element has been there for decades now, since the very beginning of the web, but most of the time it was set to screen or print, to let you style the page for rendering on a screen, so on the screen of a computer, or without most colors and background graphics and just embellishments, bells and whistles, for just plain printing. So the trick is extending the syntax allowed for the media attribute to introduce screen, which remains as the first word for backward compatibility, and whatever follows. What follows is a query, logical query, based on properties, in this example, max device width, properties defined by the CSS media queries standards. So there you can have keywords as defined by the standard, the CSS media queries standard, and as supported by the browser. So there's a standard, the browser supports, hopefully, the standard, and which means that the browser provides values, runtime dynamic values for max device width and all of the keywords from the standard. But we have no control, of course, and I would say unfortunately, on the values that we read through the browser. We have to trust the browser. So what we are saying here is that we like to use the small.css to style the page if the maximum, if the width of the device is at most 480 pixels. If the browser, when it goes through the first link element you see, checks the expression, and it gets a Boolean response, true, false. If it's false, it proceeds and goes to examine the next statement. It just ignores the statement. Otherwise, if the answer is true, it applies the small CSS and still goes to the next, because all of the link statements you find are processed, and if the answer is to the media query is true, the CSS is applied. So you can even have, if you don't put in the right order the link statements, you can have that, the CSS is overridden at the next step. So at the end of the list of link statements, there will be some CSS applied, which could be just one CSS or the result of applying multiple CSS with whatever results from overriding of possible expressions. But yet you have a tool now. Max device width, essentially, takes into account the max device width is a subtle difference. There's a device width which says the real screen device. Now, on a mobile device, the width of the device and the width of the screen of the browser is the same, because browsers run full screen. On a computer, device width is the screen of the computer, so the physical hardware. Instead, screen width is the viewport size, so the size of the browser window. So typically, you don't want to use, if you are creating a bunch of media query expressions to serve desktop and mobile devices, you want to use max screen width instead of device width to take into account the effective viewport. For mobile is the same, but not for desktops. And from there, we started having some sort of onion-style development. Like in an onion, gurus said us that we have to start from optimizing the style, the CSS, to render the content starting from the smallest possible size we intended to support. And in Bootstrap language, Bootstrap is a framework that supports and promotes responsive web design, pretty popular, written by Twitter guys. So, and they say that they use the XS suffix to identify classes that are specifically rendering content for small screens. And then they say, you start from there, and you build your page that in a way that it renders well with XS devices, and then you go to small devices, just a bit larger, and then medium devices, and then large devices. And XS, SM, MD, and large, they are typically associated with a breakpoint, with a number of pixels. Every framework sets the number of breakpoints for, in this case, and the number of pixels each breakpoint is related to. But of course, I mean, if you create your link statement yourself, as we had in the previous slide right here, we have two breakpoints, one set at 480 and the other one set at 960. But you can have as many as you like, and you can decide, of course, to define the physical width as you like. In Bootstrap, we have 768 pixels to be the size of X small, up to, I think, 992, the small, over 992 up to 12,000, the medium, and over 12,000 pixels for the large. In the upcoming Bootstrap 4, the breakpoints increase to 5, and there is an extra small, XX small new size, which I think is up to 5, around 5 or something. It's beyond 600 pixels anyway. So there's a new medium, a new measure that better represents smartphones, essentially. So they called this onion-style development mobile first, which I think is kind of misleading. I mean, it's true in the sense that you start with focusing on the mobile rendering first, because you typically start from making your content nice to show on small devices, and then you just add more and more and more and more. So it's mobile first in the sense that the first case you focus on is the mobile, so the X small. But at the end of the day, you deliver the entire onion, regardless. That's the point. So it's mobile first, but actually is large last. So in the building of the code, you start from mobile first, but when it comes to deploy, when it comes to the amount of bytes effectively downloaded, you download the entire onion. And if you download the entire onion on on X small device, you download the entire onion just to show the heart of the onion. And this is what my friend Maximiliano Firtman, a popular person in the mobile space, just tweeted yesterday. I think he was referring to a new version of a LinkedIn, I don't know if it's the website, application, or whatever. And he says, I'm sure that downloading 122 megs is faster. Yes, it was ironic. There was a bit of irony there. It's faster than mobile optimized web content. But that's true. That's it. That's the point. The amount, if you go responsive web design, the amount of information you download, regardless of the device, is always the same. So if you have a very large website, okay, that's really large. But anyway, if you have several megs, you download several megs regardless of the device. And on a small device, you download that huge amount of information just to hide it. Because the cons of responsive web design is that responsive web design is only exclusively about styling. And even though it's called mobile first, it ultimately implements one vision of data for the largest possible device. And you download the info related to populating the largest possible scenario. It's about the screen width, and all about the screen width. And the screen width is not reliable because, say, a Chrome, a browser window, resized to, say, 400 pixels, running under powerful Wi-Fi in your office, is treated by responsive web design in exactly the same way as a mid-quality smartphone connected over 3G which has a 480 pixel. There is no difference for responsive web design, whether it's Wi-Fi or not, whether it's a resized browser window or it's a full screen small device. Now, again, whether these two, you want to treat in your specific application these two scenarios differently, that's up to you. You know that, because saying that you should be doing this or that, it's a matter of religion. And religion is never much to do with the brains and with the business orientation that software requires. So graphically, if you have two windows on a PC, you have just a resized browser window that features 480 pixels horizontally, and you have a full screen smartphone, responsive web design will apply the same CSS style because it only looks at the screen of the viewport. So the same information is rendered, so it shows nicely in both cases. But the same amount of content is downloaded on both devices, and the amount of content is never tailor-made for the real size. What it displays is tailor-made for the size, but not what is downloaded. And, well, if this sounds surprising, think of how it goes, how it works. You download from the server. And the server knows nothing about the screen width. Not at the moment, at least. Because there are emerging standards, like client hints, that may change this, but in the future. At the moment, the server knows nothing about. The only information you can process on the server is the user agent string. Beyond that, the CSS media query is processed on the client side. So the downloaded info is always the same, and it has to contain everything that can be used to fill whatever screen width you intend to support. So you download always for the largest possible, and then you display for what is the current width. So you download the same amount of content, and well, it can make a huge difference if you are connected physically on Wi-Fi and you have a powerful laptop, or you have a smartphone over a slow 3G connection. That could make a huge difference, and you know if it really makes a huge difference for your specific situation. Technically, there are a few things that CSS can do, and a few others that CSS cannot do. So CSS can do for you the following things. It can show or hide elements in the DOM. It can position elements around the page. It can cut and reflow content. If you use the overflow attribute, or if you use the float CSS attribute, so that the content bounces when it reaches the edge of a container, it bounces on the next line. So you can do this kind of things. But the most important of the things you can do here is show and hiding elements. But the info for those elements is still downloaded. CSS cannot do the following things. Will never make you able of doing the following things. You cannot change the layout. You cannot say, okay, if this is a smartphone, do this, otherwise do that. That requires code. And the code must be the if, the logic, the conditions must be evaluated against what? User agent analysis, or perhaps screen width. We are back to square one. We need to bring in the DOM information about the real device capabilities if the screen width, if we recognize that the screen width is not going to give us the granularity of information we need to process and render our pages the best. Another situation with responsive web design, you have no chance. You can present users different use cases, so different actions, different buttons, unless you download logic and graphics for all possible scenarios, and then you decide which one to hide. And of course, you cannot serve different markup, which was precisely the point that in the previous tweet, the guy Maximiliano was pointing out at. So, web optimize the content, look at the device, and download intelligently the markup that best fit that case. And the simplest thing you cannot do with CSS, recognizing effectively the operating system. You cannot do that. No way, no chance. And now, second half of the presentation, let's try to go beyond responsive web design, but not until we identify two big categories of features typical in web pages that don't find a proper answer with responsive web design. And if you Google for those things, you will find plenty of frameworks or attempts to solve the problem of images and the problem of presenting different use cases on a per device basis. Now let's focus on the image. So how can you resize images on a per device basis? We know that in HTML we have just the IMG. Okay, it doesn't work. Okay, just the IMG tag to display images. At the moment, that's the only way, fully supported way. The IMG tag, which takes the SRC source attribute and points to whatever JPEG, PNG image you have somewhere on some HTTP server. That's it. The IMG tag is processed by browsers, and browsers at the moment do nothing more than just connecting, opening another request, another socket to the specified URL, download the bits and render the bits. Period. That's all they do. There is the picture element that is emerging and will become at some point a standard supported across multiple browsers. Some browsers already implement and support the picture attribute with the syntax you see there already. And the idea here is that we don't have just an image, we have a picture, and the concept that makes a picture different from a plain image is that the picture can be a collection of related images that browsers pick up the specific bunch of files to display depending on media query expressions. So when we try to read the content you see on screen now, we see that at some point the browser has to render a picture choosing the source from a variety of physical images. So if the minimum screen width is 992 pixels, then he has to choose between large -1 JPEG and large -2 JPEG. Using the 1x and 2x has further information depending on the knowledge the browser may have about the pixel density of the current display. So if the browser implementation is sophisticated enough to know how many pixels it is made of, the screen is made of, which is an information, this one that makes sense mostly for devices, iPhone devices, just Retina devices, then the browser that recognizes this syntax will download large -2 on Retina displays and large -1 on other, or that would be the default. But you also see that while this kind of thing may work on mobile devices, may not apply to desktops. Let's ignore for a moment the specific aspect of images. Let's think about touch capabilities. I might have a laptop, and if I use a laptop like this one here, which has a touch display, and I'm using the display mounted, physically mounted, that comes with the operating system and whatever, the browser for this particular machine will have something, may typically have something that contains the touch keyword. So I can detect from the user, also from the user agent, it is a touch device. But if let's say that this is not a laptop with touch capabilities in the screen, but I connect this device to a separate monitor which has a touch capability. No way. Okay, no way. The computer may detect that I'm connected now to a separate external monitor that has touch capabilities. So it's really something that it's tough to detect. And unfortunately, the only reliable way we have to know information is if the browser makes the information publicly available in great detail and without lying or without hiding for whatever, mostly commercial reasons. Anyway, back to the screen here. We have another raw media, mean width 640 pixels, and then we have another collection of images that on a per density basis have MED-1 and MED-2. We also have as a default, so if we have a screen width which is lower than 640, then we choose small-1 or small-2. If the browser doesn't understand, is an old browser and doesn't support, knows nothing about the picture element, everything will be ignored but the IMG, which is there as a fallback. So this code works if you use it now. If the browser works as a polyfill, I would say. So if the browser is smart enough, new enough, sophisticated enough to recognize the syntax, it works and it's fine for you. But now, look, it means that on the server side, in the images folder of our web application, we need to have a large-1, large-2, MED-1, MED-2, small-1, small-2, at least 6 different copies of the same logical image. So we multiply by 6, in this case, the complexity of managing images on the server side. Now, my personal experience, 4 years ago, my company won the bid to provide the mobile application for a tennis tournament, one of the most important tennis tournaments, not a Grand Slam tournament, but just a little bit smaller. So the home page of our mobile application was displaying the image of the moment, so the highlights picture. So reporters took pictures from the courts and they were uploading the picture for the app to display, and that was changing 3, 4, 5 times a day. Because of the pixel density, we had to, even 4 years ago, distinguish retina displays and everything else. Because on newest of the time iPhones was still mounting retina displays, we had to double essentially the size of the image. But we couldn't ask reporters to upload 2 copies. They were just uploading 1 image. Okay? And then we had some stuff working on the images and just, first place, cutting the image to exactly the ratio right for the app. And then multiplying the size of, resizing, having 2 copies of different size 5 times a day. So 5 times a day and only 2 copies. That was still too much work. Was boring. Was do we really need to we already had 3 updates today. It's enough. Let's keep the next for tomorrow. So even in situations much less problematic than the one I depicted here, in the real world, you are generating a lot of work for the people behind the website. So you still need to have a significant workforce, and you don't have to underestimate the work required to maintain such a kind of thing. So before you think it's a smart solution, it is. But it is from a developer perspective, from a business perspective. I'm not sure it's really smart, even though it works beautifully as a solution. What else? Look at these 2 pictures. Okay, the picture, the size is the same, but actually the first one, the one on the left, where the player is smaller, okay, that is just a badly took screenshot of a far larger image. But that was the image that was took from, let's say, the reporter, and the picture that was uploaded for displaying to some website. Now, let's say you have to choose a thumbnail for this image. If you simply resize the image, you get something which is an orange block with a couple of pixels. Okay, so imagine this is originally it's an image that for the most part that represents the tennis court, the clay tennis court, and then there is a few pixels red and a few pixels black representing the player. So it's not a great picture, to be honest. But anyway, let's say that's all you have. That is all you have. Now, how would you calculate? How would you run? How would you resize that to get a reasonable thumbnail? If you simply resize the image, you get an orange block with a couple of pixels at the bottom, period. That's it, that's all you get. The thumbnail I suggest is, it's a square moved around the picture just to take the size of the thumbnail, but centered on the player, on the part of the picture that we consider, in the specific case, relevant to use as a thumbnail. More in general, this is called artwork. So there is another dimension to choosing images. It's not simply that you have the large image and then you resize to different smaller numbers. Sometimes when you resize, artwork gets into play, and it's the human brains, it's the eyes that suggests how you should resize. So it's not necessarily something you can blindly delegate to a tool. In some cases, handling multiple images leads you to control and human analysis, hard work. Now, solutions. By the way, everything that I'm presenting now is freely available, in some cases with some special situations. So there is no contract, no subscription, nothing that requires you to pay money. So everything is free, in this particular case, up to an amount of traffic, which is fairly large anyway for most cases. The first tool I want to present is called Image Engine. And you can find more information on the Wurfel.io website. Now, Wurfel is a framework that has been around for several years now. Originally, it was open source, but it's 5 years now that it turned into to be a commercial product. But for many scenarios, especially JavaScript-related scenarios, is freely available. When I say Wurfel is essentially, there are two companies, 3 in the world that use Wurfel. And are 3 companies whose logo is characterized by letters. So there is one company who has the G as the logo, another one has the F, another one has the double P. So it's Google, Facebook, and PayPal. Those guys use Wurfel. Wurfel is a framework, it's a cross-language framework, so some of them use the PHP version, others the Java version, the C#. There's a question? I'm done? Okay. Okay, a few minutes, okay. So this is the tool. Let me show you how it works. So this is a sample page that has 3 images, as you can see. And the interesting thing is that every image I put from my website, tennis1.jpg, is prefixed with the Wurfel free account. So I'm telling the browser to connect to try.lite.imageengine.whatever and download, acting as a proxy, essentially, as a CDN, as a smart CDN, the image from my website. So what happens technically is that the code in the Wurfel framework, so behind the try.lite whatever, connects, downloads from my website the image. That's why I have to indicate the full path from my image. I cannot use a relative path to point to my images. So they download, they cache in their cloud and serve me the image properly resized for the effective device that was detected. Because when the browser calls IMG, serves the IMG tag, it passes the user agent. So the Wurfel endpoint knows about the capabilities of the device, gets the image and resizes that. It can do that in a couple of ways. It can do that in a default way, so just looking into the size of the device, or just following the instructions I can provide. And in particular, I'm saying that I want this with the W500, I'm saying I want the image resized at most to 500 pixels. So I have the power to control the resize process, or I can say, look, do whatever you want, except, and in that case, the default behavior is that everything is done.
Sorry, Dino. We unfortunately have not. We already for 2 minutes extra time, and we have unfortunately no time.
Okay, I will finish just presenting you with one more slide, one final slide. This one here. I invite you to point your devices on this QR code and see what happens. What happens is that you will be pointed to the URL that is typed at the bottom, at the top, and that will will tell you essentially what kind of a device you have. This is done using a JavaScript framework, using Wurfel. I've checked this morning with my device and it works beautifully. So, so the code behind, can I dismiss for a second? The code behind that is essentially the following. This is the code that does the trick. So can I scroll it up a little bit? Yes. So this is the line you need to have to enable This is the line you need to have to enable Wurfel detection on the client. And in this way, an object is injected in your DOM, and this object is called Wurfel. And if I can manage to scroll this a little bit, and okay, let's see that locally. And this is the expression you have to check in your code, Wurfel.formFactor, which takes values like smartphone, tablet, and 10 more values. At the cost of injecting a script element, you get free an object injected in your DOM that tells you what is the name, Microsoft, Internet Explorer, iPhone, whatever, the full name of the device, the form factor, tablet, smartphone, Xbox, whatever it is, and a Boolean value whether or not it's mobile or desktop. All this is for free. Thank you very much for your time. Talk after the room.